Good morning, everyone. Welcome to this lecture, and we are moving into a new chapter.
Sir, good morning. Today our chapter branch, few of students have gone to cricket stadium.
I can't hear you clearly, sir.
Sir, today we have a cricket tournament is there. Sir,
So please type. I can't hear you properly.
okay. Okay, sir.
Okay. I hope everything is fine. Shall I start the class?
Yes, sir.
Okay. So welcome, and this is a brand new lecture. We are dealing with work, power, and energy. That is the name of the chapter, and we'll be dealing with these three things: work, power, and energy. Now, I guess you have heard about these words before. Let us start with the first heading, and the first heading is work. What do you mean by work? Now, the way that you use work in your day-to-day life and the way work is treated in physics might be slightly different. In everyday life, we can use work for a variety of things. Right now, you are studying, you're also working. I am teaching, I am also working. But when we have to measure the amount of work is a physical quantity. In physics, even though sometimes when we are doing work in physics, it may not be treated as a work. So the word work may mean a slightly different concept in physics. Now, what do you understand by work in physics? Anyone has any idea? When do we say work is done in physics? When do we say work is done in physics? Yes. Any idea? You must have heard about this word, work. Any idea when do we say work is done in physics? Yes? Can anyone say anything? When do we say work is done in physics, basically? Do you have any idea? Yes or no? You must have heard this word work, right? So do you know anything about work? Any idea or no? You've not heard. This is the first time you're hearing the word work in physics. So there in your 9th standard, 7th standard also. Have you heard it or not? Yes? Have you heard the word work?
Yes, sir.
Okay. What have you heard about it? I mean, is there anything that reminds you when you think about work in physics? Yes? Say, don't be shy. See, what do you understand by the word work? Yes?
Product of magnitude of displacement and component of force along the direction of displacement is called work.
See, you know about work and you are not speaking. That is exactly what work is. In physics, when we talk about work, In physics, whenever we talk about work, work is always done by a force. So, to have any sort of work done, you must have a force. And then, what this force should do? If I am applying a force on the wall, well, I might be losing some energy. I might be doing some work, but in physics, that will not be treated as work because when I apply force on this wall, the wall does not actually move. So, when you apply a force on a body and this force produces a displacement of the body in any direction except the direction which is perpendicular to force. So, force cannot do any work if force and displacement are at right angles, are at 90 degrees. So if the angle is not 90 degrees and if the force is applied and the body is displaced, angle between force and displacement should not be 90 degrees, then we say work is done by the force. So whenever force is applied and the body is displaced, work is said to be done. The only condition is the angle between force and displacement must not be 90 degrees. Do we understand this? Yes or no? We understand this? Yes or no? Okay. So this is what you must remember about work done, and you are supposed to write it, not just look at it. So you are supposed to write it as well. For work to be done, two things must be fulfilled. Force must be applied, and the displacement must not be in a direction perpendicular to force. The angle, or you can say this in a different way, angle between force and displacement should not be 90 degrees. Then you say work is done by a force. Then you say work is done by a force. Then you say work is done by a force. Do we understand this? Then we say work is done by a force. Now, what is the formula of work done? That is the next thing that you must understand. So to understand this, what we will have to do is draw a small diagram. You have a body of mass m, and then you apply a force F. This is a vector, and let us suppose that the body displaces like this. The small displacement is ds or dr, whatever you call it. The angle between this force and displacement is theta. Then, since the displacement is small, you can write it. The small amount of work done, dw, will be the dot product of F with displacement. The small amount of work done is the dot product of force with displacement. That implies the total work done, and I will write work done as delta W. It is integral of force with displacement. Or you can write it as integral of, this is a dot product here. Have you heard dot product? Dot product of two vectors. The dot product of two vectors is F into dot product of two vectors is the two vectors multiplied by the cos of the angle between them. Do we know this? Yes or no? Yes. So this is the work done by a force. I'll give you 1 minute to note it down. Have you noted it down, beta? Have you noted it down? Yes or no? Okay, I'll give you time. Note it down. Shall we move ahead? Yes? Okay. Now, the simplest case of work done can be understood by taking the force as constant. The force that you apply is constant. When I say constant force, force is a vector, so it must remain constant in magnitude and it must remain constant in direction. So, if we talk about the work done by a constant force, now the work done by a constant force delta W, it will again be the integral of F dot ds, but then the force is constant, so you can write it as F dot your displacement delta R. Here delta R I am writing as displacement. Displacement. It is the dot product of F with the displacement. It is a dot product of force with displacement. But again, this formula is only valid if work is done by a constant force. I can also write this formula like this: magnitude of force multiplied by the magnitude of displacement multiplied by cos theta, where what is cos theta? You can understand this in this very simple way. For example, if this is a surface, you have a body of mass m, and I apply a force like this, and let us say I displace the body from this position, the original position, to this new position. Remember, the force is constant, so force does not change. So if I move this body like this, let us say that the displacement of this body is delta R. As you can see, the direction of displacement is like this. Do we see this? Body goes like this. Force is applied like this. If the angle between force and displacement is theta, you can see this. So the work done by this force will become F into displacement into cos theta. Do we understand this? This will be the work done by this force. F into displacement into cos theta. Everyone understands this? Okay. Now, there is another way in which I can write this. Remember, work done by a constant force is F into displacement into cos theta. I can write this formula in this way also. I can take F cos theta together and then multiply it by the displacement. I can take this F cos theta together and multiply it by the by the displacement. Now, if I do it this way, what it actually means is, if you look at this diagram, in this diagram, what I can do is I can resolve the force into two components. One component is F cos theta, which is parallel to the force. One component is F sin theta, which is perpendicular to the force. Do you see this? F cos theta and F sin theta. F cos theta and F sin theta. F cos theta, this green one, this green component, as you can see, is in the direction of force. F sin theta, this blue component that you see, it is perpendicular to the direction of force. This is the green component. This is the green component here. So you can write work done as, component of force in the direction of displacement multiplied by the displacement. Do we understand this? You can also write it like this if you want to. So you can now write it, work done by a force is equal to what? Is equal to what? The product of is equal to the product of component of force along displacement or in the direction of displacement, the product of component of along displacement and the displacement. Do we understand this? Yes or no? Do you understand this, everyone? Okay, so I'll give you 2 minutes to note it down. Once you are done, please let me know. Everyone has noted it down? Okay. Now, the next point about work done is, what type of quantity is work done? Is it vector or is it scalar? Yes, you must know this. Is work done vector or scalar? Well done. It is a scalar quantity. What about the unit of work done? SI unit? You can call it Newton into meter, or you can also call it joule. Do we know this? Yes or no? Now, work done is a scalar quantity. So we start. Since work done is a scalar quantity, we can understand what will you mean by positive and negative work. Now, I'm only talking about work done by a constant force, but this is also valid for variable force. Now you can see work done is written as F into displacement into cos theta. Now remember, force and displacement, these are vectors. And whatever we are using here, they are magnitude of this vector. So they are always positive. So we have three terms here, F, displacement, which are vectors, and we are using their magnitudes. And then we have a cos theta term. And now I'm saying that work done can be positive or work done can be negative. What do you think? Which term out of these three decides if the work done is positive or is the work done negative? Who will decide the nature of work, whether it is positive or negative? Whether it is positive or negative, who will decide? Who will decide whether the work done by a force is positive? What decides? Which factor out of these three will decide whether the work done is positive or negative? Yes.
Force and displacement.
Force and displacement. How do they decide force and displacement? I'm looking at the equation. Just looking at the equation. In the equation, you have three terms: force, displacement, and cos theta. When we are using these three terms, force and displacement are magnitudes. They're always positive. So what is going to decide whether your work done is positive or negative?
Direction.
Direction decides whether your work done is positive or negative. So basically this cos theta decides whether your work done is positive or negative. When cos theta is positive, that means your theta is acute angle. The angle between force and displacement is acute. Then the work done is positive. If the value of cos theta is negative, that means the angle theta is obtuse. That will make work done as negative. Work done can also be zero. When will it be zero? It can also be zero if the angle is 90 degrees or your force is perpendicular to displacement. And that is why we say if the force and displacement are perpendicular to each other, if force and displacement are perpendicular, then the work done is zero. Remember, this is a very important concept. When the work done, when the force and displacement are perpendicular to each other, the work done by that force is taken as zero. Work done is a scalar quantity. It can be positive, it can be negative, it can also be zero. Are we getting this? Yes or no? Everyone understands this? Now let us try to understand it by a simple diagram. Let us say this is my fourth quadrant. You can see this is x-axis and this is y-axis. This is minus x, and if you want to say this is minus y, just to understand this. Now imagine that your force is like this. Your force is in this direction. Your force is in this direction. Then if your displacement is acute, your displacement is in this direction. Let me write the displacement as delta r. As you can see, this angle is acute, or your displacement is in this direction. That means in the first or the fourth quadrant, if your displacement lies, your angle will be acute. And in all this region, in this first and the fourth quadrant, if this is the case, your work done by the force will be positive. Do we understand this? If the angle between force and displacement is acute, work done by the force is positive. But if your displacement is here in the second quadrant, or your displacement is here in the fourth quadrant, you can see the force is here, but the displacement is like this. Then your work done in this quadrant, the second and the third quadrant, your work done would be coming as negative. If your displacement is in the y direction or minus y direction, if this is your displacement, your angle becomes 90 degrees. Do we understand this? In this case, your work done would be 0. So this angle decides whether your work done is positive or whether your work done is negative. Do we understand this? Yes or no? Okay, I will now again try to make you understand it. This small table. Have you noted it down? So this is it. Positive work, when the angle between force and displacement is 90 degrees, we say that the work done by the force is positive. So you can also write it in this tabular form. Everyone understand what is drawn here? In the first case, the pink case, you can see the angle between force and displacement is acute. Angle is less than 90 degrees, and therefore you say that the work done is positive. In the second case, the green case, you can see the angle is between 90 and 180. Obtuse angle, the work done is negative. Do you all see this? Give you 1 minute to notice down. Don't have to write everything, beta. Please understand what you are writing and just write that point. Don't have to write it in English. You can write it in any language that you understand. Just have to understand the meaning of positive and negative verb. Whatever is there on the whiteboard, you don't have to copy everything down. And I see all of you just copying everything down. Do not copy everything down. Try to understand it and write it in your own language. Do we understand this, everyone? I see this very bad habit of students just copying everything down from the board. That is not going to help you. Copying everything down will not help you. Understand what is written there. If you understand it, just write it in your language where you can understand. Are you getting my point, everyone? I'm not, see, the language of the book or the language in which I write, I can understand it. But can you understand it? You must write in the language that you understand. Okay, shall we move ahead? Shall we move ahead? Have you written it? No? Shall we move ahead, beta? Okay, let me know once you are done.
Done, sir.
Boys, other center, are we done? I can still see them writing. Done? Just write it in your language that you understand. If you have understood something that I'm telling you, just write it in your language. When I say your language, that means in the language that you understand. It's all about your understanding. It's not about my language or my understanding. So these are some examples of work, positive work and negative work. If a man is lifting something, his force is upwards. His displacement of the body is also upwards. Work done is positive. But when I'm lifting something, the force of gravity is downwards. The work done by gravity is negative. Do we understand this? So basically, positive and negative work only means what is the angle between force and displacement. If the angle between force and displacement is acute, less than 90, work done would be positive. You can see in all these cases, the angle is acute, so the work done is positive. In all these cases, angle is obtuse, more than 90 degrees, and therefore the work done is negative. You all understand this? This is just for your understanding. You don't have to write everything. You just have to understand it. Do you understand this? Okay. Now, sometimes the angle between the force and work done can be 0 or it can be 180 degrees. Remember, cos of 0 is 1 and cos of 180 is -1. Do you know this? Yes or no? In that case, you can say that the force is going to do maximum work. So when does a force do maximum work? When the angle is 0, that means force and displacement are parallel. Then it does positive maximum work. Or when force and displacement are opposite, force is like this and displacement is like this, then it does negative maximum work. Positive maximum work is F into displacement because the angle is 0, cos of 0 is 1. So the positive maximum work is F into X, F into delta R. The negative maximum work, or you can call minimum work, if you call it negative, if you call minimum, it is F into S. It is not minimum. The amount of work done is same. It is just in the opposite direction, and therefore you are getting minimum. Do you understand this? Yes or no? Have you noted it down, bacha? Okay, we have talked about positive work. We have talked about negative work. We have talked when the work done is going to be positive, when the work done is going to be maximum in the positive direction, when the work done is going to be maximum in the negative direction. Now let us see the case where work done is zero. Work done, remember, work done is force into displacement into cos theta. So in three cases, it is going to be zero. The first case, you don't have to write the example. The first case is when the force is perpendicular to displacement. The example is given when the coolie is moving your luggage, keeping your luggage on the top of your head. We know that he's doing a lot of work, but in physics, his work done is zero because force and displacement, the gravity force and displacement are perpendicular. So in physics, he is not doing any work, but we know that he is doing a lot of work. So that is the first case in which work done by this force is zero. Why it is zero? Because the angle is 90 degrees. Do we understand this? The second case, if there is no displacement, if I am trying to push this wall, but this wall is not going anywhere, I might be losing a lot of energy. I think that I am doing work, but in physics, that work done is zero because there is no displacement. Third case, if there is no force, then there is no work. Do we understand these three cases? Case number one, case number two, and case number three, yes or no? So please note them down. Understand them and note them down.
Done, sir.
Shall we move ahead? Okay. This is the first question that we are going to solve. Everyone has noted this down? Everyone? Everyone has noted down the previous thing? Yes or no? Noted down?
No, sir.
Then say na beta. can't, I can't, the problem with me, I'm not a mind reader. I can't get into your minds and see what you have done or not. If you don't tell me, then how will I know? Please let me know. Let me know once you are done. You don't have to write the examples there. You just have to write what I've underlined, nothing else. Let me know, beta, once you are done.
Completed, sir.
Well done. Just let me know, beta. Okay. This is the question now. I have given you a question. Oh no, not the question. This is the question that I have given you. From where I see, I can see three forces here. Can you tell what are the three forces that are that are there on this block? What are the three forces? What are the three forces which are acting on this block? We have been doing this in the last chapter. What are the three forces which are acting on this block? What are the three forces that are acting on this block? Don't write the question, answer my question first. What are the forces that are acting on the block, beta? Then you can write the question.
Gravitational force, normal force, frictional force.
There is no friction here, this is smooth. So from where what I can see, beta, there are three forces. One is this 10 Newton ka force. So you have to find out the work done by this 10 Newton ka force. Then the other force is the normal reaction force. I hope you know what is the normal reaction force. And the third one is the gravitational force. So you have to find out the work done by these three forces. The 10 Newton force, the normal reaction force, and the gravitational force. I'll give you 2 minutes to do this. The mass of the block is 5 kg and I have moved it by 2 meters. Everyone can do this? Yes or no? Good. Anyone got any answer? Or shall I do it? Anyone got any answer? Yes or no? Okay, then I'll do it. Let me find out the work done by the 10 Newton force. What is the work done by the 10 Newton force? I look at the force. I look at the displacement. Displacement is 2 meter. The direction of displacement is here. The direction of force is like this. Work done by this force, work done by any force is, what is the formula of work done? Can anyone tell me the formula of work done? What is the formula of work done?
Force into displacement.
Formula of work done is force into displacement into cos theta, where theta is the angle between force and displacement. When I talk about this 10 Newton work, the work done by this 10 Newton force, how much is the force? How much is the value of force? Tell me.
10 newtons.
10 Newton. What is the displacement?
2.
What is the angle between force and displacement? What is the angle between force and displacement? The body is getting displaced like this. The force is like this. What is the angle between force and displacement? It is 0. So it is cos of 0. Both are parallel. As you can see, this one and this one, they are both parallel. So cos of 0 and cos of 0 is 1. So the answer is 20 joules. 20 joules is the answer for work done by this 10 Newton force. Now let us move and find out the work done by the normal reaction. How do I find the work done by the normal reaction? First, I will have to draw the free body diagram. Weight of this body is 50 kg, 50 Newton. The normal reaction is N. I can write what is the value of normal reaction. We have been doing this for a lot of time. The value of normal reaction is 50. The value of normal reaction is 50. Now let me find out the work done by this normal reaction. Work done by this normal reaction. Remember, this normal reaction force is upwards. What is the value of this force? It is 50. 50 multiplied by the displacement is 2 multiplied by what is the angle between normal reaction, the force, and the displacement? What is the angle? No one knows the angle? Okay, the normal reaction is upwards, the displacement is like this. So the angle is 90. So it will become cos of 90, and cos of 90 is 0. Therefore, work done by this force is 0. The third thing I have to find out is the work done by gravity. You have to find the work done by gravity. So how do you find the work done by gravity? You find the gravitational force. And how much is the gravitational force? Gravitational force is the weight of the body weight of the body is 50 newtons multiplied by the displacement of the body is 2 multiplied by what is the angle between weight and displacement. Weight is going downwards and displacement is forward. You can see the angle between them is 90 degrees. Cos of 90 is 0. Therefore, the answer for this part is 0. So the work done by 10 Newton force is 20 joules. Work done by normal reaction is 0, as well as the work done by gravity is also 0. Why it is 0? Because the angle between these two forces and the angle between the force and the displacement is 0. Do we understand this? Do we understand this, boys, girls?
Yes, sir.
Yes or no? So this is how you have to do it. We will continue with this in the next class. Take care. God bless all of you. Bye bye.